Y'all are being silly. Number 1. Angle of elevation and depression. Finding a cathedral height. So you have the picture drawn for you. This is 60 degrees. Of course, this is a right triangle, and this is 300 feet. What? You don't have to be ugly. The angle of elevation of the top of the cathedral from a point 300 feet away from its base, and now this is not at eye level because there's not a person standing there, it's just from the ground this time, is 60 degrees. Find the height of the cathedral. So I'm finding this value. So what trig function uses opposite and adjacent? Tangent, that's right. So the tangent of 60 degrees is equal to what? X over 300, right? Opposite over adjacent. This is number 1. Now, you could have solved this as a 30-69 triangle. Did anybody do that? You have the short leg. Yeah, I would have done that too. But either way works. This is actually on your unit circle. What's tangent of 60 degrees? Most of the time when you're using application problems, it is tangent. What's the tangent of 60 degrees? Square root of 3? How do I get x by itself? Multiply by 300. This was a good one because there were 2 different ways you could do it. I could leave it written this way. I could have taken out my calculator and done tangent 60, gotten a decimal approximation for that, and then solved it that way. Degrees, since this is in degrees. The other option would be looking at this knowing that it's a special right triangle. It's a 30, 60, 90, and I have the short leg. So remember, if you have short leg, then to get to the long leg, you take short leg times the square root of 3, and to get to the hypotenuse, you would do 2 times the short leg. So either way you chose to do that. That was 3 different ways of doing that one problem to find that height. Does that make sense? Everybody good? Everything okay? Yes? Give me another one today. Which one? 2 more or number 2? Oh, okay. Oh, that's a good one. So number 2 is from a point 100 feet from its base, the angle of elevation of the top of the arch of the is da 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 da. So we're looking at an angle of elevation, so we're looking up at something, we're looking up at the top of this arch. And this angle of elevation looking up, it says is 34 degrees, 13 minutes and 12 seconds. How tall is the monument? And you're standing 100 feet away. Well, the first thing I need to do is get this in just degrees, and it's in DMS. This is where you had trouble, right, Brett? Brett says he can't convert from DMS to degrees or degrees to DMS. DMS is degrees, minutes, seconds. So it's 34 degrees plus 13 over what? Plus 12 over what? I thought you didn't know how to do it. This is on your calculator now. I don't know. Yes. No, you'll have a calculator for part of it, for part of the test, and mine. Yeah. Yeah. Unit circle questions are no calculator. Yeah. What I do, what? I did 13 divided by 60 and 12 divided by 3600 and added them together on my calculator. No, you gotta fill in the whole unit circle. Yes, I'll give it back to you. I got a grade. Somebody from calculus graded them. Every blank was 1 point. There was 100 blanks on the test. There's actually 85 on the quiz and 15 on the back. No, like, can you use your quiz on the test? Oh no, you're gonna have one to fill in. Yeah. It probably will. It'll probably be something that you'll keep getting on, spiraled into all the tests until you have it ingrained in your brain. Yeah. Yes. No. No, it won't count personally. All right, now I'm back to a unit triangle. Is that what you just said? Okay, you've got the 30, 60, 90, and the 45, 45, 90 triangles. Okay, this is what I'm looking for. I have the degrees. I would make sure that my calculator is in now degrees. And so what trig function am I going to use? Sine, cosine, or tangent, and why? Tangent, why? I have the adjacent, I need the opposite. So, katoa, right? So the tangent, I'm going to change this from the DMS to the 34.22 because I'm going to need to use my calculator. It's going to equal x over 100, multiply both sides by 100. Yes. It's a decimal, but yes, you put it in there. Some old hippie caught another hippie. Some old hag cracked all her teeth on apples. Not another old, just another hippie. Come up with a better one. All right, so this would go in my calculator, making sure I'm in degrees. And if you put that in your calculator, you should get that it is approximately 68 feet. Is that right? Nobody's answering me. Yeah. 68.01. Since this one was since it was 01, I just did round it to 68 feet, but you could, whatever. Unless it's specified, it doesn't matter. Feet. Just does. Other questions? I'm not doing all of these, y'all. Okay. No. Okay, you had 1 through 10, and I've done 1, 2, and now this is 3. These aren't even hard, y'all. The picture's drawn for you. This says the angle of depression from the top of Smoketown Lighthouse, 120 feet above the surface of the water, to a buoy is 10 degrees. How far is the buoy from the lighthouse? There's your picture. That's the light shining. Thank you. Yeah, I'll even draw the buoy for you. Nope, but I do now. There's a picture. It's the buoy. It's what it looks like in the book. Thank you. I'm glad it's just all right for you. This is 120 feet. Thank you. Thank you. I appreciate that. All right. How do I find the distance? Because whatever this distance is, the one across the top is the same. So how do I find x? Tan. Are y'all starting to see a pattern here? Most of 9 times out of 10 is tan. Tangent of 10 degrees is equal to what? What? There you go. Different this time because it's opposite over adjacent. So this is a little bit of a different solve here. As I go through and solve this, I can still multiply by x on both sides. And I have x times the tangent of 10 equals 120. And then what I would do is divide by tan 10. And so I could put this straight in my calculator this way. 20 divided by tangent 10. And I would get approximately 680.55. Because tangent is opposite over adjacent, right? So I've got this triangle. Here's my theta. So the tangent of 10 is going to be the opposite side over the adjacent side. The opposite of theta is 120, and the adjacent is x. So this is my equation. So to solve it for x, I needed to get that fraction going, right? So if you multiply both sides by the denominator here, the x is gone. So I end up with x equals, or x times the tangent of 10 equals 120. Still have to get x by itself. Oh, you could have done that and gotten a decimal and then solved from there. You still should come back. So if you put tangent 10 in your calculator, then you had 0.176 equals 120 over x. So if you rounded it, that's why your answer is different in the end, because you rounded it early. And so that would have caused this. You should still have 600 and something, do you? If you had, let's see, 120 divided by, if you use 0.2, yeah, that's all it is. That's just round. You did the process right. It was just a rounding error. What if, and this is a little bit of new stuff here. I'll come back to number 4. What? You said you didn't do that, Brett. This is a little bit of new stuff. This is, yeah, I'm just going to show you how to do this. What if where was I? Let's say I had this triangle and I asked you to find theta. Find the value of theta. Okay, so as I'm looking, I guess I should label this more. Name it what you want. All right, more trig application. So if I gave you this triangle and I said find theta, find the value of theta, any ideas what I can do? Do I need the other side? If I was use cosine, you're exactly right. If I was asked to solve the triangle, solving a triangle means finding all sides and all angles. But if I'm asked to find theta here, I can use a trig function since it's a right triangle. I would say that the cosine of theta equals, well, what does it equal? Did you take her? What is the adjacent side? What's the hypotenuse side? So here's the dilemma. The dilemma is finding out the value of theta here. So what I do, you look on your calculator, and we're not going to do any more with this function other than just this, using it to solve. We will have, if we have time at the end, we'll come back to the graphs of these, which is the chunk we skipped here in the middle. Otherwise, we'll hit it in AP Calc. To get theta by itself here, I'm going to use the inverse. Remember, inverses cancel each other out, right? Anytime you have inverse, the inverse of addition is subtraction. To get rid of addition, we do subtraction. So what I can do is I can say that theta is equal to the inverse cosine of 7 over 12, okay? And what this means is I'm looking for where the cosine value is 7 over 12. I don't know that. That's not on my unit circle, so all I'm going to do is use my calculator. Okay, again, now this one, not so much mattering if it's in degrees or radians, because if it's in degrees, then my answer is going to spit out in degrees, and if I'm in radians, my answer is going to spit out in radians. I'm going to keep it in the degrees that it's in. I'm going to do second cosine, 7 over 12. Keep it in degrees, yeah. And it tells me that theta is approximately 54.31 degrees. That's the only new stuff today. Okay. So it's just, if you're given two sides and you need to find theta, then you just use the inverse. Just so you understand what inverse is, if I told you that the sine of theta equals the square, yes, I do not. If I told you that the sine of theta was the square root of 3 over 2, what would you tell me theta was? You could find it on your unit circle. So I'm looking, sine is what, the y? Where is y square root of 3 over 2? 60 degrees. So I was going to say, just so that you see, take out your calculator and tell me what is the inverse sine of square root of 3 over 2 on your calculator. How do you do what? Second sine. Mode. Hit mode. Any other questions? Okay. Did you just sneeze? Oh, okay. Your eyes were one. I thought you were fixing to cry. I was like, oh my gosh, it's not that bad, Liza. I promise. No, what's your question? Sorry. Is that where they're This was just, yeah, it is. It's another problem. I was showing you an example of why why the inverse works that way. Everybody okay? All right. Let me give you your work because I don't even know what's going on right now. Yes, it didn't correlate. That's why I drew 2 lines under it. That means it kind of relates. Like, see, homework, the title. No. Let's do. I know.